So let's apply what we have learned and use the Benner's general model of chemical behavior to analyze an event from the point of the container. And I've pulled up the slides at the lower right-hand corner so we could start to think about something in a different way. And let's see if we come up with similar answers or different answers.
Facility near San Juan, Puerto Rico. Gasoline overflowed and...
So the first step is identifying the product that is losing control. We have gasoline with a UN number of 1203, an emergency response page of 128. So what do we know about gasoline? Creating one of these hazmat maps will tell you everything right there at a glance. So we have the ERG page, which I wrote on the bottom, the UN number. It's a flammable liquid with a moderate vapor pressure. We could see that the biggest risk is fire, and it does not have reactivity to it. We have our exposure range, both short-term and long-term, from the NIOSH Pocket Guide, as well as the lower and upper flammability ranges. And so there's the value of being able to look at something all at once. We also have the vapor density. We see that it's very heavy, which means it'll fall to the ground. And the specific gravity is 0.72, which means that it'll float on top of water and it does not mix with water. Believe it or not, long-term exposure to gasoline can be a carcinogen. So I really like these hazmat maps. Again, adding more to them gives you a bunch of information just at a glance. So let's see what we could do now to start to fill in our model.
October 23rd, 2009. A massive explosion rocked the Caribbean Petroleum Terminal Facility near San Juan, Puerto Rico. Gasoline overflowed and sprayed out from a large above-ground storage tank, forming a huge vapor cloud which ignited.
So by using the model, I have gasoline which spilled out, and haven't quite figured out what caused it to spill out or overflow, and the spill out ignited, causing a 170-acre vapor cloud. Now coming back to our emergency response guide for a general flammable liquid that does not mix with water, we should eliminate all ignition sources and equipment that's being used in the area and try to stop the leak if you can without risk, which we couldn't do. A vapor suppressing foam would have worked, but of course this is too big of an area. So it's a large spill, which means we would, water spray may reduce vapor but would not prevent it from reaching its ignition source, either in a closed and an open space. And even though this is outside, the tanks were close together. So this particular page in the emergency response guide doesn't tell us all that much. It's pretty general, but let's keep watching the video and see what we see.
The explosion damaged nearby homes and businesses. Petroleum leaked into the surrounding soil, waterways, and wetlands. Fires burned for more than 2 days, destroying 17 of the facility's 48 storage tanks.
The CSB found that current EPA and OSHA regulations are inadequate to control the hazards from facilities like Caribbean Petroleum that store large quantities of gasoline and other flammables. As a result, the company was not required to conduct a risk assessment of the danger to the nearby community from its operations, and the company did not have to implement safeguards that could have prevented the explosion.
On Wednesday, October 21st, 2009, Caribbean Petroleum Corporation, or CAPECO, began a routine transfer of more than 10 million gallons of unleaded gasoline from a tanker vessel docked 2.5.
So we have 10 million is our potential.
Half miles from the facility. The only storage tank inside the tanks. An electronic transmitter card sent the liquid level measurements to the control room. But the transmitter card on tank 409 was out of service, so operators were required to manually record the tank level readings once every hour, measurements to the control room. But the transmitter card on tank 409 was out of service, so operators were required to manually record the tank level readings once every hour. At 10 p.m., the night of the 22nd, as tank 411 reached maximum capacity, operators fully opened the valve to tank 409. At that time, an operator read the level of tank 409 from the side gauge and reported it to his supervisor. The supervisor estimated that tank 409 would be full at 1 a.m. But shortly before midnight, tank 409 started to overflow. Gasoline sprayed from the vents, forming a vapor cloud and a pool of liquid in the tank's containment dike. The CSB determined that a total of nearly 200,000 gallons of gasoline, the equivalent of 20 full tanker trucks, was released from the 6 vents on the tank. On a warm, windless night, the gasoline vapor cloud grew to cover an area of 107 acres.
That's really important there, warm, windless night, because the gasoline is heavy, right? The vapors fall down to the ground, and then they're not being moved. And there are evacuation distances based on weather conditions in the emergency response guide.
At midnight, the tank farm operator was ready to perform the hourly check of tank 409. But before reaching the tank, he noticed a strong odor of gasoline. He alerted the dock operator to shut off the flow of gasoline to the tank. The tank farm operator and another operator met the supervisor at the edge of the terminal. There they observed a white fog rising approximately 3 feet above the ground. The supervisor sent one operator to the security gate to stop anyone from entering the site. Then the supervisor and the tank farm operator drove to an elevated point away from the cloud to try to identify the source of the leak. Meanwhile, the pooled gasoline flowed through open valves in the containment dike toward the wastewater treatment area. There, the vapor reached electrical equipment, which ignited the cloud. A flash fire raced back toward the storage tanks. 7 seconds later, there was a massive explosion, registering 2.9 on the Richter scale. The time was 12:23, approximately 26 minutes after the overflow began. Soon, 17 of the facility's storage tanks were engulfed in flames. Fortunately, the 3 Capeco employees escaped the tank farm, and there were no fatalities. Flames from the explosion could be seen from as far as 8 miles away. The shockwave damaged approximately 300 nearby homes and businesses. Fires continued to burn for over 2 days.
The CSB determined that Capeco had an unreliable system for monitoring and controlling the level of gasoline inside the storage tanks. This set the stage for the incident.
The CSB found that the float and tape measuring devices used by Capeco were prone to mechanical failure. These devices were poorly maintained and were frequently not working on multiple tanks at the same time. Also, the CSB discovered that lightning strikes and cable breakages often disabled the electronic transmitters that sent tank level measurements to the control room. Capeco routinely took weeks to repair problems with the level monitoring system. Instead, operators checked tank levels hourly and manually calculated the time it would take for tanks to fill.
System was the only control system Capeco used to avoid overfilling a tank. When that system failed, the facility did not have additional layers of protection in place to prevent an accident.
Most tank filling operations are, for the most part, governed by a single layer which has to be backed up with other layers.
The CSB notes that good engineering practice would have called for at least 2 additional layers of protection at Capeco, an independent high-level alarm and an automatic overfill prevention system. An independent high-level alarm can detect and alert operators to the danger of an overfill, even if the primary system for measuring the tank level fails, as it did at Capeco. An automatic overfill prevention system goes even further and can shut off or divert the flow into another tank when the tank level is critically high.
So if you saw the progression of the general model throughout the incident, you can see that it changes over time. And so every time there's a change between the vapors leaving the tank to the vapors being ignited to the explosion, the model changes along the way, and then the hazards usually grow and expand and contract. And throughout each one of these different processes, the emergency responders are using the DECIDE model, and that's why it's in, they're constantly reevaluating. And there's an example of how you would use the behavioral model to decide the best approach, which is sometimes to do nothing to avoid harm.